Hi everyone, this is Arishjin Ingeo, one of the reporters from Group 4, and now I will be discussing to you the lesson 5 entitled Electric Field and Conductors. First, let's define what is conductors. So, conductors are the materials or substances which allow electricity to flow through them. So, they conduct electricity because they allow electrons to flow easily inside them from atom to atom. So, in other words, conductors have a low resistance to the flow of electric charge. And also, they allow the transmission of heat or light from one source to another. So, as you can see in the pictures, we have examples of conductors. We have copper, gold, water, graphite, and all other metals. So, why is it metals considered as a good conductors? They are considered as a good conductors because they have a large number of free electrons that can move through the material in response to an electric field. In addition to that, conductors are often used to transfer electrical energy from one place to another or to transform electrical energy into other forms such as heat or motion. So, one of the examples na atong nagamit for example when kanang sa brownout is generators, diba? So generators is a good um example for that because kanang we use generators to convert it into mechanical energy. Kanang samtang naglihok ang generators, they convert it into energy which is to electricity, and that could light up our bulbs. And also another example is heating elements in electric stoves like ovens and water heaters. So, matingala mo nga nung ang naapil man diya ang water. So, water is a good conductor also because it contains very large amounts of solute and ions. Then, the movements of these ions is what causes electricity to flow. So now, electric fields inside of charged conductors. We have here electrostatic equilibrium. So what does it mean? So in electrostatic equilibrium, the condition established by charged conductors in which the excess charge has optimally distanced itself so as to reduce the total amount of repulsive forces. Once a charged conductor has reached the state of electrostatic equilibrium, there is no further motion of charge about the surface. So, meaning from the word itself, electrostatic, meaning there is no movement of charges and it is stationary. So, a charged conductor tends to redistribute its excess charges evenly around itself. We say that the conductor is in electrostatic equilibrium since there is no movement of charges, and we have also in electrostatic equilibrium there is a following properties and characteristics. So now, a conductor in electrostatic equilibrium shows the properties that there are no excess charges inside a conductor. Now, charged conductors that have reached electrostatic equilibrium share a variety of unusual characteristics. One characteristic of a conductor at electrostatic equilibrium is that the electric field anywhere beneath the surface of a charged conductor is zero. So meaning the movements of charges are zero. If an electric field did exist beneath the surface of a conductor, or inside of it, then the electric field would exert a force on all electrons that were present there. This net force would begin to accelerate and move these electrons. But objects at electrostatic equilibrium have no further motion of charge about the surface. So in electrostatic equilibrium, if conductors is in equilibrium, then the charges are not inclined to move, or it is stationary. Therefore, in this state, all points of the surface of conductors are at the same electric potential, and the potential difference between any two points inside the conductor is zero. This, of course, presumes that Our does not surround a region of space where there was another charge. But however, if there are any existing charge that is introduced into the conductor, then it will distribute itself until the balance is achieved. So, meaning the I, if there are excess charges nga enters ana nga conductor, then it will find ways, it will move around until it reaches the surface where it can spread out uniformly. So, just remember that in a conductor in equilibrium static equilibrium I mean electrostatic equilibrium is the charges is zero, and once na ning excess nga mga charges diha kay it will find a way, and it will find a way to redistribute uniformly until the balance is achieved. Muna kana first properties or characteristics sa conductor in electrostatic equilibrium. Now, the second characteristics of conductors at electrostatic equilibrium is that electric field upon the surface of the conductor is directed entirely perpendicular to the surface. The motion of electrons, like any physical object, is governed by Newton's laws. One outcome of Newton's laws was that unbalanced forces cause objects to accelerate in the directions of the unbalanced force, and a balance of forces causes objects to remain at equilibrium. So this truth provides the foundations for the rationale behind why electric fields must be directed perpendicular to the surface of conducting objects. So electric fields are perpendicular to charged surfaces because electric field lines emanate from or terminate on charges, and charges on a surface are oriented perpendicular to the surface. But what if what happen if the electric fields of conductors are not perpendicular? So this means that the charges are not evenly distributed on the surface of the conductor. So, take a look on these images provided. So, naadiha, a component of E parallel to the surface would move excess charge. Now, take note nga, basta gani conductor in to achieve electrostatic equilibrium. So, the direction of the movement of electric field must be in perpendicular. So, dili man diya perpendicular lang inyo nakita. So, in this case, since parallel man iyang movement, the charges will experience a force that will cause them to redistribute themselves in such a way that electric field becomes perpendicular to the surface. So in this component that acts upon the newly acquired excess charge to distribute the excess charge over the surface and establish electrostatic equilibrium. But once reached, there is no longer any parallel component of electric field and no longer any motion of excess charges. So in the third picture or images provided, we have here the electric field must be ning kuan na siya no, perpendicular na iyahang kanang directions sa each location niya. So meaning there is balance. Now let's proceed to the last characteristics or properties of a conducting objects at electrostatic equilibrium. So the electric fields are strongest at locations along the surface where object is most curved. The curvature of the surface can range from absolute flatness on one extreme to being curved to a blunt point on the other extreme. So take a look on the images provided. It was a lightning rods. So lightning rods is a very pointed conductor that has a large charge concentrations at the point. So so now we have here surface curvature, increasing amount of curvature from flat to blunt point. So a flat location has no curvature and it is characterized by relative weak electric fields. On the other hand, a blunt point has a high degree of curvature and is characterized by relatively strong electric fields. So, a sphere is uniformly shaped with the same curvature at every location along its surface, as such that electric field strength on the surface of a sphere is everywhere the same. So meaning if sharp iyahang shape pa-curve iyang location or directions, meaning strong iyang charges sa conductors, and it will result into strong energy or strong impact. To sum it up on the third characteristics or properties of conductor at electrostatic equilibrium is that the electric field is related to the curvature of the surface. So when a conductor has a curved surface, then the electric field lines are more concentrated in regions where the surface is more curved and less concentrated in region where the surface is less curved. This phenomenon is known as the electric field and surface curvature effect and can be understood through Gauss law. So later on, or if you don't know about Gauss law, it states that the electric flux through any closed surface is proportional to the net charge enclosed within that surface. In the case of a conductor, the net charge enclosed within any closed surface is always zero, because any excess charge on the surface of a conductor is redistributed in such a way that the electric field inside the conductor is zero. Therefore, the electric field lines must terminate or begin on the surface of the conductor. When the surface is curved, the electric field lines must also curve to follow the surface. So in regions where the surface is more curved, the electric field are closer together. And in regions where the surface is less curved, the electric field lines are farther apart. This is because the curvature of the surface affects the amount of charge that is distributed over a given area, which in turn affects the strength of the electric fields. So that would be the end of my report. So I will give the floor to the next reporter. Thank you everyone for listening.